In this video, we'll be talking about how to do a limiting reactant problem. So a limiting reactant problem can be recognized by a stoichiometry problem where you're given amounts of two different reactants and asked for the amount of the product. So for example, an Alka-Seltzer tablet contains 1.7 grams of sodium bicarbonate, that's NaHCO3, sodium bicarbonate, and 1 gram of citric acid. There's citric acid. Determine for a single tablet dissolved in water which ingredient is the limiting reactant being the ingredient that gets used up first, what mass of the excess reactant, meaning whatever one does not get used up first, is left over when the reaction is complete, and what mass of carbon dioxide forms, carbon dioxide being one of the products of this reaction. So an Alka-Seltzer tablet, we're familiar with it, used for heartburn or stomach upset, and when you drop it in a glass of water you see it bubble as it dissolves. So the two primary ingredients are sodium bicarbonate, which is baking soda, and citric acid, which is the acid found in citrus such as lemons. When those two come together, this is a base and an acid, they react. An acid-base reaction. Carbon dioxide bubbles are formed, that's when you see the bubbling, and the byproducts are water and sodium citrate. But we're only worried about the one product, carbon dioxide, in this particular question. So how do I determine what the limiting reactant is? Common mistake I see is students assuming whichever one you have less of can be assumed to be the limiting reactant. In this case, we have less citric acid than sodium bicarbonate. But you can't assume that, because if a recipe requires twice as much flour as sugar, then you may run out of flour before sugar, even if you have more flour. Same idea with chemical reactions. We require 3 times as much sodium bicarbonate as we do citric acid. So we may actually run out of sodium bicarbonate first, even though we have more of it. So how do we go about doing this? Well, first of all, in any stoichiometry problem, when we're comparing two things in a chemical reaction, and we see they have a ratio, in this case it is a 3:1:3 ratio, comparing the two reactants and the product that we're interested in. These are molar ratios, so we have to first be in moles before we can make any sort of comparison. We're starting off in grams. So step number 1 of this problem is to convert those grams to moles. So to convert from grams to moles, we do this by dividing by the molar mass. So to get the molar masses of each, we add up the atomic masses of each element. So go ahead and do that for sodium bicarbonate, that is 84.01 grams per mole. For the citric acid, that's 192.12 grams per mole. And then for carbon dioxide, it's 44.01 grams per mole. So let's go ahead and for our two reactants, convert them both to moles. So starting with the sodium bicarbonate, we have 1.7 grams. When we divide by the molar mass, grams will cancel and we'll be left with moles. And then do the same thing with the citric acid. Now at this point in the solution, my method differs a little bit from what you'll see in your textbook if you're following along. I'll be using the method shown in the 2-page spread in figure 3.7. I prefer this method because rather than determining how much of each reactant is needed based on how much of the other reactant, if you go ahead and determine which one is the limiting reactant according to which one makes less product, then you've killed 2 birds with 1 stone, because at the end of that you not only know which one's the limiting reactant, but you've also answered the question of how much product was formed. So I'm going to use that method. So starting with my moles of each reactant, the way this method works is I'm going to go ahead and determine how much product each one made. Now the products, I've got 3 different products here, but the question was specifically asking me for the mass of carbon dioxide. So I'm going to focus on the product carbon dioxide and not worry about the other 2 products. Whichever one of these reactants, sodium bicarbonate or citric acid, makes less carbon dioxide, that one is our limiting reactant. And then we also will know how much carbon dioxide has formed, and we will have answered question C at the same time. So to go ahead and calculate this, we're going to take our moles of each reactant multiplied by the molar ratio to get to moles of carbon dioxide. So for the sodium bicarbonate, so molar ratio is what we're looking for on top. We're looking for carbon dioxide, so carbon dioxide goes on top. And the number in front is a 3. And on the bottom we put what we currently have, drops down to the bottom. We currently have sodium bicarbonate, so that's going to go on the bottom. 3 there. And we have a 3 in front of sodium bicarbonate, so 3 goes on the bottom. That way when we multiply by the molar ratio, the sodium bicarbonate will cancel. And 3 over 3, so the number doesn't change, and we would be producing 0.2024 moles of CO2 if sodium bicarbonate is our limiting reactant. Now let's do the exact same thing for the citric acid. Multiply by the molar ratio to figure out how much carbon dioxide that can produce. So 3 carbon dioxides on top, and we've only got one citric acid on the bottom. So when we multiply this across, citric acid will cancel, times 3, so we get 0.01562 moles of carbon dioxide. So between the two of these, we made less product, less carbon dioxide when we used the citric acid as the limiting reactant. So that must be our limiting reactant. So citric acid is our limiting reactant. Now not only do we know what our limiting reactant are, so we've answered that question, but we also know how much carbon dioxide forms, but the question is what mass. So we still have one more step because we don't have mass, we have moles. So just like to go from grams to moles, divide by molar mass. To go from moles back to grams, we do the opposite, so we multiply by molar mass. And the molar mass of carbon dioxide, don't forget, is 44.01. So we're going to take those moles of carbon dioxide and convert them to grams. And now we have our final answer for part C. The mass of carbon dioxide produced. So in the original question, we've answered which ingredient is the limiting reactant. It was the citric acid. We've determined what mass of carbon dioxide forms. So the last part here, part B, asks what mass of the excess reactant is left over when the reaction is complete. So if citric acid is our excess reactant, then the sodium bicarbonate, citric acid is our limiting reactant, then the sodium bicarbonate must be our excess reactant. So we need to determine how much of this was actually used and subtract that from how much we actually started with to determine what mass was left. And I'm just going to leave it in moles for now just because that's fewer conversions to do. So to determine how much sodium bicarbonate was actually used, we're going to take the moles of carbon dioxide that was formed and work backwards to figure out, well, how much carbon dioxide would be necessary to produce those moles of CO2. And all we're going to do is take our molar ratio from here and flip it. So now instead of CO2 being on top, CO2 is what we're starting with, so it drops to the bottom. Factor label method back from chapter 1, very beginning. Whatever unit you start with goes diagonal, so if it starts on top, it drops to the bottom. So same deal here as we've been doing since chapter 1. The unit we want goes on top. We want sodium bicarbonate, so sodium bicarbonate goes on top. And the ratio from the balanced equation is 3 to 3. 3, carbon dioxide will cancel, and we'll be left with how many moles of sodium bicarbonate are required. Now we know how many moles we started with. We started with 0.2024 moles of sodium bicarbonate, and now we're saying that this 0.01562 moles of sodium bicarbonate is how much is necessary, how much was consumed. So to figure out how much is left over, it's a simple subtraction. So 0.02024 moles of sodium bicarbonate we started with, subtract, and this is how much is remaining. But this is in moles, and we want the mass. So again, to go from moles back to grams, we multiply by that molar mass. The molar mass for sodium bicarbonate again was 84.01. So we are left with 0.0388 grams of the sodium bicarbonate remaining. So we've answered all three questions. Which one is the limiting reactant? It was the citric acid. What mass of the excess reactant is left over when the reaction is complete? We just answered that. And what mass of CO2 forms? So we have the mass of CO2 that forms and the mass of our excess reactant that remains. And those are the three types of questions that you will see with limiting reactant problems.